So the next session is very important because, it's all about technology, situational awareness, and what goes into actually managing such projects that you just saw from a technological angle. We have a very interesting person, Sanjay Rajesh Desai, the chief architect at Airbus, and he's going to talk to you about the technology perspective on security and surveillance. So, Rajesh.
Hi, good afternoon, everyone. I think my job is 80% done. The reason is, I think both previous speakers has given you the entire case studies, and I am going to talk about the technology aspect of it. Though everyone might have covered when they are implementing the technology aspect, so I'll just cover the security aspect majorly from the homeland and border security. Now these two speakers, they have spoken about the safe city. Now I am going to talk about, take it to the little different level where it will talk about border security. Okay, so the question is, are we safe as a nation? And I mean, we know what's happening, and we have seen this. Why I asked, are we safe as a nation? We are not even safe as a whole world, where we have seen so many attacks everywhere. So that means the biggest problem is some terrorists or some activities which are happening there, everyone is entering and trying to create a problem. So how can you avoid this? Now, earlier speaker talked about how do we save a particular Puri incident or Kumbh Mela incident. That means we are talking about a certain place. Now, if it is securing the certain area is still a solution. But when it comes to the entire nation, how do we secure our nation? And if you see, India has such a periphery where it is completely covered 3/4 by the water, and then we have different neighbors. And in such scenario, and you are seeing every day, I think this is some 100 infiltration happened just in last couple of days. Having such a country, how do we protect? I mean, every day our soldiers are giving their best, and you know what's happening. At the end of the day, you know what is the result. Now, how do we make the technology such a way that how do we protect our soldiers? How we can build a complete command and control? How everything can be managed through a centralized network? Okay, and so when you talk about security now, there are different type of securities are available, like you can say personal, organizational, somebody talk about safe city, and the interesting thing aspect is also about this homeland and border security, which I am morely going to discuss that. And when it comes to the homeland and border security, it is basically about what kind of a sensors you deploy, how the solution you will get, and it is not a single solution which I can simply give you, okay, you connect these sensors and this is going to solve your problem. No, the reason is it is basically also on how the demography is. So you have a sea, so what you are going to do with the sea coast, what you are going to do with the Kashmir borders, what you are going to do with our internal city. So the solution cannot be the same. So solution has to be completely complex in, it is anyway so complex in nature, and it's about which are the sensors you are going to take, right? Now, these are some of the sensors which we have listed, and I think already most of us has already spoken about is that we use access control, video surveillance, radars, UAVs, and satellite imaging. So these are the different kind of sensors we can use to build a network of those. But can really this solve the problem? If I use simply all these sensors, can this really solve the problem? If you use these sensors, we have to do something about. By using this sensor, we have to actually do the surveillance. When it comes to the surveillance, okay, I mean, we are also seeing that most of the CCTV cameras have been put in every place, and we say still there is some infiltration or some other bad events happen. Now, how that happens if there is so much of security and surveillance being done? So basically, we need to find out or figure out. My earlier speaker spoken that they have so many sensors and so much data is getting collected. What is important is when so much of data is coming, can we actually find out some event? That means the huge number of, when you have so many sensors, a lot of data is coming, but what is happening is can you actually figure out what is the event which is going to take place or which has happened? That is a more crux. That means when I say we have a video camera, I have a radar, I have some other sensors, can I do a data fusion? So ultimately it boils down to the data fusion, and from the data fusion can I get an event which will tell me, yes, this is the problem or this is the threat, or how do we react to that such kind of a threat. So that means I think this is already been covered in this one, that for now take an example of Puri, they have given this is an operational requirement for the Puri, that means the road has to be cleared, the temple has to be done. That means this, what I am saying is, this operational requirement is the most important thing to give any of the solution in the security business. If there is no proper requirements, it is very difficult to build a solution around it. When I say requirements, we need to have what kind of a sensors I am going to put, what is the use of it, how I combine them, what is the network, how do I going to process it, what is the latency required, is it real time, what is the recovery of it. So all this, and what are the different algorithms I run on it. So those are the most important stuff. Now, as I mentioned you that I will be more running on this homeland and border security and not really talk about the other aspect, because which has already been covered. Now in the homeland and border security, as this picture shows, when it comes to the border, we cannot rely on one sensor, and we have multiple sensors. When you have multiple sensors, what I mean is we require a radar, we require cameras, we require a satellite, we require a UAVs, we require a response vehicle, and all these things has to work simultaneously suppose there is an event, somebody is infiltrated, it has been picked by the radar. Okay, radar is giving me some picture. Yes, then what we will do, we will immediately check whether a camera is picking it. If the camera is picking it, yes, the immediately alert should go to the response vehicle. Response vehicle has to go to the place and figure out what is happening, and then comes the strategy of the actual people who are actually dealing with it. So this is not a simple solution. So it has to be completely an integrated solution. So that means when I say integrated solution, it means it has to be integrated surveillance architecture. So when I say integrated surveillance architecture, how the architecture should look like, that means I would have, I take a case of in India where we have a maritime surveillance. That means most of we are 3/4 of is by sea. So that means I want a maritime surveillance. And if you remember 26/11, when Mumbai attack happened, the people actually came from the small boats. Now how do I detect a small boat where the people are coming? How do you know that they are not the same fishermen which are coming? So how do you differentiate that? So that's the reason we require a very high maritime surveillance. When I say maritime surveillance, that means we require a ship with the radar sensors which can detect a swimmer, which can detect a small boat, which can detect a rubber boats. Okay, so that means that is kind of a sensors I need to put in. Next comes the land. Now you are seeing in the Kashmir border where every other day we are seeing there is some infiltration happening, right? Now, even people we have a night vision devices to figure out, but a guy to just keep watching how difficult it is in a 24/7 in a very, very difficult atmospheric condition. We need to understand it's the atmosphere. I've been into a defense, so I've gone there, and the atmospheric condition we cannot stand there. Forget about doing the surveillance by a human eye. So in such a difficult condition, we require to support them with the proper sensors. When I say sensors, the sensor also needs to work in all weather condition. So the -20 degree it goes, -30 degree it goes. Can your sensor works in -30 degree? If not, there is no use of the sensor. That means whatever we are building, we have to build to which can actually cater for such things. So then we have a CCTV system which most of you have seen, and then I said the response vehicle system and access control. These lot of people and lot of things everyone is discussing about. Yes, these things are already available. All these sensors are available. Each sensor works beautifully. They give a very good output. we can do. What will happen if I take all these sensors, because they are distributed in a 40 kilometer radius, 40 to 50 kilometer radius, that is radius defined, maximum radius which a sensor can, can do a surveillance. That means I need to do a data fusion, and by using the data fusion I would actually do a command and control, and those actual threads will be presented into the display. Based on that, somebody will take the command and control. Now this is another, I think architecture where it is only talks about the access control and the video surveillance. I think you have seen in the previous slides where we have a face recognition, we have a tire killers, we have access control. I mean, these are the different sensors and how those actually work. So background of that is that we have so much of data coming in, we have so much of servers to process it, and all this information actually goes into the central location. From that central location, some command and control, and somebody will take the decision. It's not going to be easy when we have a kilometers running this center and the data is coming in such a huge rate. The another architecture which also talks about the border security solution, and I'll tell you this is one of the most difficult thing to achieve in as far as the Indian context, and why. Now I have given some little example about 3-tier architecture. It can go up to 5 tiers maximum. Now when I say 5-tier architecture, what is that? Is about if you have a radar or if you have some sensor which you have put it in a Kashmir, say you have sensors put it in a Kashmir, you have sensors put it in this sea coast border, and you have the information, okay, the radar has tracked something, some ship has come and some infiltration has happened, some aircraft might have also you have seen some movement of some helicopter. This information is all the way available 24/7. Now when this information is actually processed, where it gets processed? It has to get processed at the place where the sensor is. What is the use of that if it is just processed at that place and just kept it there? So this information has to be then sent to somewhere else where I do multi-sensor data fusion. That means one sensor is at 40 kilometer, another sensor is at another 40 kilometer, another sensor is at another 40 kilometer, and I have hundreds and thousands of sensors, can you believe? And then I do processing of them and get this data passed to somebody else, where somebody takes all this different data and do the data fusion. When I say data fusion, it is not about one sensor, it is about multiple sensors. I have a radar, I have a camera, and I have other sensors. And then I do the processing, and then it will be further, I get some kind of an alert out of that. What do I do with it? Alert. So suppose what happens when Prime Minister wanted to see, I wanted to know what is the security, how it has been implemented, what is my borders are doing. So if Prime Minister walks into a room and say, I want to know entire Indian coastline, what is happening? What is happening in the Kashmir? What is happening in the coastline? What is happening in the east, west, north? I wanted to know. Can we give a comprehensive picture, a real-time picture to our security agencies from the border? And that's what I mean, different layers of architecture. That means a radar which is picking any threat can be seen in real time in Delhi. Suppose there is something event is happening in Kashmir, can a Prime Minister see this event in Delhi in real time with a live video of both radar track video, the video coming out of the thermal images, and can it be done? And that's what we are talking. And this is the kind of a network, I mean, to say it looks okay, we will connect it on a network backbone, but this is what it looks like when it's observed. So each is actually as a cluster. So each will form a cluster, and then you connect this cluster to create a complete top-down architecture. And you see there is these different surveillance towers, and then those surveillance towers are connected and information is processed, then it goes to the different headquarters. From the different headquarters it goes to the national headquarters, and from the national headquarters no one wants to see everything. I want to exactly see what is the threat. I mean, no one at the national level would like to see, okay, this camera is there, this is going to, no one is bothered about that. I want to see only what is a threat, is there a threat, that's all, and what is the action being taken. This is something about I think already we have talked about the video content analysis, And the important thing is that how do we, if there is a person, how do we differentiate? So basically we require to run different algorithms to figure out the threat. Is it really some vehicle, or is it really some person who is walking, or he carries some gun, or what is his? So basically there is something called as analyzing the track behavior. So behavioral analytics is also important here. So when it comes to the person, when you detect a certain person, we also need to do a behavioral analysis, and that is what is also been done. Sorry. I think the next is about the UAVs. But I mean, UAVs is going to play a major role, and going forward I think UAVs are the one which is going to play a major role in all the surveillance. Now why UAVs is so important? We can put on different sensors on the UAVs and we can actually monitor. We can put a radar, we can put an IR sensor, we can put a video, and we can capture the picture, stream it down on the base station. On the base station we can do analysis, we can know what is a real-time threat. Now if there is some fire somewhere, or some places where no one can go, if there are some, suppose in the POK region, if you wanted to go and you have a UAV which is going and gathering all the information for which we are processing sitting inside the control center, I mean what best you want. And that is what is the future, and that's what whole of our surveillance is moving towards. Okay, just to give a brief idea about what is that, with a short time, I mean, what I'm saying is this is possible for, this slide is basically for all those startups which I'm giving, because by using a simple GPU card which are just available in each and every computer, you can do a parallel computation. That means you can actually do true parallelism and can process the data. The question is, when I asked other question that so much data is coming, how do I do a processing? I would require huge kind of a hardware. The answer is, I mean, if you ask me, and my personal experience goes, it can be done by a simple computer with actually a GPU card, and you can really do a true parallelism by using the GPU cards with a real parallel programming language. And if you can do that, you can actually perform 1 trillion instructions per cycle, right? And if that much of processing power is available in a computer, you can actually do, and this is actually going to, give us how the way the data is getting processed. And now, I mean, I will give you, a little different experience about how, which are the radars which are available and can be used, because I feel this is a little different topic because it's a radar, and most of you talk about TV camera surveillance, and how do we pick, if somebody wants to give us some solution, how do we pick a radar? And what is it? So that depends upon the kind of specification. So one is about perimeter surveillance radar, which you can put it for any of these fence, oil refineries, airports, and we can do a processing. We can find out whether a person is traveling. We can figure out whether the person is moving a vehicle. I mean, all these things we can figure out with the radar, and we also are given what is the range in which it is possible. Then we can, I discussed you that India needs a lot of coastline, and we require a lot of coastal surveillance radar, and by using this radar we can actually figure out what I said, that you can mount this radar on a ship, and this actually tells you whether the person is swimmer, or is it some vessel coming, or it's some small boat, and we can actually figure out this information, and that is what these radars can be used. Now I covered the perimeter surveillance, the coastal surveillance, now comes the ground surveillance, and this is the ground surveillance radar it does. And these are some sensors, and this is some future technology. When I say future technology, it is basically going to be the completely network of sensors, and it is a data fusion. Signal intelligence is one of the areas where a lot of things are happening. So how do we use a signal intelligence inside the surveillance? And definitely big thing is about data analytics. Data analytics, number of data fusion, and how much rate you can, how much time you can process this information, because in real time behavior, what I say is 1 second is a maximum time elapsed. You have to act everything on the 1 second. Yeah, thank you. Yeah.
Good show. Wonderful. Yeah. Ashwini, can you come and do the honors for Rajesh?